Right, so we are asked to expand this for the first three terms, okay, up to x squared. So we're going to use the binomial expansion here. However, you can probably see straight away there's a problem, yeah, because with the binomial expansion, it always has to be 1 plus, okay, or 1 minus, but it has to be a 1 here, okay. Unfortunately here we've got a 4, so we're going to have to deal with that. But before then, let's just rewrite this, yeah. Let's get it so that we've got a bracket, and that we have the bracket on the top. So you remember with the square root, it is bracket to the power half, okay, that's what square root means, and then we'll take it up to the top, okay, so that we have 4 minus x to the power negative half, okay. Now we have a problem, yeah, as I said, because it's not 1 there. So how do we deal with that? Well, we've got to make it so that there is 1 there, okay, so we've got to manipulate this, okay. We're going to manipulate it so we have 1 there, so we can expand it, because at the moment we cannot expand using this formula, okay, using this expansion. So what we do is this, right, we get it so it's 1, so we factorize out that 4, okay, we factorize out the 4. So how do you do that? Well, let's make that bracket a little bit bigger, and let's factorize out a 4 here. So we're going to think now as if there's a common factor of 4. Now I know when you look at this, clearly there isn't a factor of 4 here, okay, but we're going to make it so that there is a factor of 4 there in terms of how we factorize this here, okay. So I've got a big bracket, I'm going to take out a 4, and then I'm going to have a slightly smaller bracket, right, okay. So the question I ask myself is then, what do I times by 4 to get 4? Well, of course that's going to be 1, yeah, which is what I want. So when I times that out, I get the 4. But then the question is, what do you times by 4 to get negative x? Well, of course, there's going to be a negative there. But if you think about it, what do you times by 4 to get 1? Well, it's got to be a quarter, isn't it? So I can rewrite this as x over 4. Okay, a quarter x. So if you think now, if I expanded this, 4 times 1 will be 4. 4 times a quarter x will be just x, okay. So that's a way of factorizing out a 4 there, okay, just by quartering that. And then we're going to close this bracket, and of course remember now it's all to the power negative half, okay. And what's good is then, because we've got this then applied to the negative half, what we can do then is take that power minus half and apply it to the 4 and apply it to the bracket. So this will be 4 to the power negative half, bracket 1 minus x over 4 to the power negative half, okay. And then this then can be worked out, because 4 to the negative half is just 1 over 4 to the power half, yeah. Because you take it down, so it becomes positive, and 4 to the power half is just the square root of 4, isn't it? So this will be just 1 half 1 minus x over 4 to the power minus half. So we've got now something we can expand. There's a half in front, but we'll come back to that later. So let's just expand this here. So 1 minus x over 4 to the power minus a half. So we've got 1 plus then the power, which is negative half, and then times x, which is negative x over 4. So I'm looking at the top of my page, okay, which is in your formula booklet as well. So I'm using that there, yeah. And then plus then n, the power, minus half, times n reduced by 1. So take away 1, minus 3 over 2, all over 1 times 2, which is 2. And then we've got to square this here, so negative x over 4, all squared. So this will be 1. Positive, this is going to be, yeah, because negative half times negative quarter is positive 1/8 x. Here then, let's take our time on this. Negative times the negative is positive, and that's going to be 3 over 4 divided by 2 is 3 over 8. Square in there, so you get x squared over 16. Square top, square bottom. So this simplifies then to be 1 plus 1/8 x plus then 3 over 128 x squared. Okay, so there's our first 3 terms that expanded. Okay, so we've done it. Okay, we've expanded it here, but remember then we have to go back to this and appreciate that we've got to times our expansion by a half, right? Because we've just expanded this bracket, haven't we? So substitute in our expansion. So I get 1/2 plus 1/16 x plus 3 over 256x squared. Okay, right, and then it says the expansion can be used to find an approximation for root 2. So they've got 3 different numbers you could put in. Okay, but it says without evaluating your expansion, state giving a reason which of these of x cannot be used. Well, if you think about it, because our bracket was this, okay, then it's valid for, okay, well, if I put minus x over 4 is less than 1, okay, the minus disappears. We're dividing by 4 then, which implies then x has got to be less than 4, the size of 4. So the one that cannot be used in part B, part 1, is x equals minus 14. So we can't use x equals minus 14 since it is outside of what the expansion is valid for. So the expansion is valid for x less than 4 or greater than minus 4. X equals minus 14 is outside of that. In part 2 then, state giving a reason which of the 3 values of x would lead to the most accurate approximation. So we could easily use x equals 2 or x equals minus 1/2. Okay, the one that will give the most accurate is this one here, x equals minus 1/2. Okay, the reason why is because it's the smallest value, okay, or the value which is closest to 0. Okay, this is the one here, because x equals minus 1/2 is closest to 0. Okay, and if you think about the expansion here, we've got x squared, x cubed. Well, as you go along the x terms here, okay, if you put in a really small value of x, then these terms here afterwards become practically 0. X cubed would be practically 0 when you put a really small value of x in. Had I put minus 2 in, it would still add in, or 2 I think it was, and it would still give us a significant value to add on. So the closer you are to 0, the more accurate the answer will become.